Hi everyone, in this video we will discuss about problems based on reciprocity theorem and Millman's theorem. So first we will discuss the problem based on reciprocity theorem. Find the current Ix in the J2 ohm impedance and hence verify the reciprocity theorem. So where is J2 ohm resistor? So here. So this is inductive impedance. So here this problem is belongs to the AC circuit. AC circuit. So here reciprocity theorem, the first condition is the circuit should have only one voltage source. The circuit should not consisting of multiple voltage sources. But Millman's theorem is belongs to the circuit should have multiple sources, not having single source. So that is the difference between these two theorems. Reciprocity theorem is condition is the circuit consisting of only one source, only one voltage source. So in Millman's theorem consisting of Millman's theorem, the circuit may have multiple sources, not only single source. So based on those two theorems, we will discuss the problems here. First, find the current Ix. Ix, where is Ix? Ix is J2 ohm impedance, J2 ohm inductor current. So first, what we will do? So we will follow the steps first. So first, we will find out the total impedance. So by using series parallel combination, we will find out the impedance of the circuit. So impedance of the circuit, total impedance of the circuit is 6.537 at an angle 19.36 ohm. So these two is parallel with series. These two are parallel with series. Then JT is equal to 6.537 at an angle 19.36 ohm. Then total current in the network IT is equal to 36 angle divided by 6.537 at an angle 19.36 degrees. So here using the principle of current division, we find that Ix is equal to IT at IT minus J 5 divided by minus J plus 3 plus J 2. So finding the IT, so we can find out the Ix here. So Ix value how much we got? 6.49 at an angle minus 36 point minus 34 minus 64.36 degrees. Okay, right. So next one, so we need to replace the voltage source into different branch in this network according to the reciprocity theorem. So first we have voltage source in this branch. Now we have replaced to this here. So without changing the current directions, we have to find out. Now we find the ZT, that is total impedance of the network, and find the total current in this network. So total current is equal to voltage divided by total impedance. So total impedance is equal to 9.8 at an angle 19.36 degrees. So total current IT dash is equal to 3.67 at an angle minus 19.36 amperes. Using the principle of superposition, using the principle of current division, Iy is equal to total current into opposite resistor by total resistance according to the current division principle. So here we have take impedances and reactances. So Iy is equal to total current IT dash into minus J5 divided by minus J5 plus 2 plus J3. So according to that, if you calculate, you will get 6.49 at an angle minus 64.36 degrees. So if you compare Ix and Iy, so these should be equal. Once if it is equal, then reciprocity theorem is verified. Otherwise, reciprocity theorem is not verified. The first case current and second case current should be equal. Then only the currents are current Ix and Iy are equal. Otherwise, Ix and Iy are not equal. Then you can say that the reciprocity theorem is not verified. So maximum while we are doing problems based on reciprocity, it must be verified. So those currents, first case current and second case current, when we are replacing the voltage source to some other branch, that branch current, that condition current and first case current both should be equal. So then reciprocity theorem is verified. Next we will see the problem based on Milliman's theorem. So find the current through 2 ohm resistor using Milliman's theorem. Refer the circuit shown in figure. So where is 2 ohm resistor? See, it is connected between two voltage sources. So according to that Milliman's theorem, we have a formula. Ey is equal to E1 Y1 plus E2 Y2 by Y1 plus Y2. Y1 plus Y2. First we have to remove that resistor. Where is the resistor? Where is that resistor? We have to remove this resistor and we have to apply that formula, Milliman's theorem formula. Then we can find out the voltage and then we can find out the impedance. So voltage once if you calculated and impedance if you calculate, we connect the circuit. Milliman's circuit is like a Thevenin's equivalent circuit, voltage source in series with the resistance or impedance. So like that we have to find out Thevenin's equivalent circuit. Then we have to reconnect the which resistor we removed in first case. So that resistor we have to remove, then calculate the current flowing that resistor. So here E is equal to E1 Y1 plus E2 Y2 divided by Y1 plus Y2. Substitute E1 Y1 values, find the E open circuit voltage. So here E is equal to 10.06 at an angle 97.12 volts. Then impedance 1 divided by Y1 plus Y2, 2.8 at an angle 26 degrees. Z we calculated. Then IL is equal to E divided by Z plus 2. Z plus, once if we calculated 2.15 at an angle 81.63 degrees amperes. So this is the final solution for this problem. So Milliman's theorem problems are very easy compared to the all other theorems problems in this module 2. Okay. So these are the problems we have discussed in this video. So once again we will briefly discuss these two theorem problems. So reciprocity theorem must have one while we are doing the problems based on reciprocity theorem, the circuit must consisting of only one voltage source. Only one voltage source. Here only one voltage source is there. So then only we can apply reciprocity theorem. So reciprocity theorem was here one this is the one case, and replace this voltage source to here and find the current in second case. So those first case current and second case current, so this must be equal. Okay. So how we have done, once again we will repeat. So total impedance you find out, total current you find out, apply current division principle. Ix is equal to It into minus J5 divided by minus J5 plus 3 plus J2. So you will get 6.49, and this must be equal to second case current. In second case, replace the voltage source some other branch in this network. Find the Iy. So how we will find out? Again similar process. Find the total impedance, find the total current, and find the current flowing in that branch current. So in this problem, so first case current, second case current both are equal, then network is satisfied, network is proved, network is verified by reciprocity theorem. Okay. And coming to this Millman's theorem problem, Millman's theorem, the condition is circuit may consisting of multiple voltage sources. So remove that 2 ohm resistor, find the current to 2 ohm resistor, remove the 2 ohm resistor current, 2 ohm resistor, and apply, find the E1, so find the E voltage using E1 Y1 plus E2 Y2 by divided by Y1 plus Y2, and Z you find out 1 by Y1 plus Y2, and find the IL line current E divided by Z plus 2. So finally what we will get 2.15 at an angle 81.63 amperes. So this circuit is belongs to Thevenin's equivalent circuit. Okay. So Thevenin's theorem problems and Millman's theorem problems, it is similar, but little bit finding the E and impedance, finding the total impedance, equivalent impedance, and finding the voltage is little bit different. Okay. Thank you everyone.